Bismillahirrahmanirrahim. Assalamu alaikum, students. In this session, we will discuss the diode models. Remember, इससे पहले session में हमने last day हमने introduction और diode के बारे में जाना, diode की construction, diode का operation, और इसके साथ-साथ जो characteristic curve के बारे में तो जाना था. Now today we start with this value of one electron volt that is derived with this formula, which is W is equal to QV, where Q represents the charge and V represents the voltage, and W represents the primarily. So after putting the values, we get because one electron contains 1.6 into 10 minus 19 coulomb charge, and for 1 volt potential difference, this value of potential difference or what primarily lead us energy lead us to 1 electron volt, which is equal to 1.6 into 10 to the power minus 19 joules. This relationship we are already familiar with, and we will be using it in computations. Okay, we have already discussed this formation of the depletion region in our last session. Now moving ahead. One thing which we have not discussed yet is the symbol for the diode. And the symbol for the diode is primarily represented with arrow and like a blocking line. So this is the symbol of a diode, which represents the P-type and the N-type. Today we will discuss the models, and that model is primarily based on this equation, which is known as the Shockley's equation. And it primarily relates the current with the voltages, so that we can primarily draw a curve. The last time हमने देखा था 0.7 volts. So this is the voltage across the diode, and this is the current through the diode. Remember, the current is in milliamperes. So as we see different quantities, IS is the reverse saturation current, and usually specified in the database data sheet as well. VD is the potential difference applied forward bias voltage across the diode, and is in ideal factor. Same. And it is usually arranged between 1 and 2, depending on usually we use n is equal to 1. And also there is a relationship which is related with the thermal voltage, the change in voltage characteristics due to the change in voltage, the change in temperature, and this is related with this formula, which represents a constant, Boltzmann constant. And the temperature is in Kelvin. There is a small associated value which is calculated in the example 1.1. Remember, this value is used in many numerical problems in this book, so it is important to maybe go through this example 1.1, which says at temperature 27 degrees centigrade, which is a common temperature or room temperature, we usually call it. Sometimes room temperature is known as 25 degrees centigrade, but this point in time it is mentioned 78. So that the temperature after addition up to 73 uh, converts it into the Kelvin, which is a 300 degree Kelvin. So in the voltage is made by using this formula and by applying the constant values. The values of the constant for K and Q on one electron volt, we get an important parameter in terms of V, which is nothing but thermal voltage. So thermal voltage at 57 degrees centigrade can be replaced by this value, which is 56 millivolts. So in many problems, numerical questions, this value is primarily used by because it is important, so we must uh, now we move towards the diode models. Skip through pages, few pages. Okay, this is a diagram which first shows the ideal semiconductor diode model. This diode model is primarily a switch. As you can see in the forward bias, diode is act as a closed switch, which we have already mentioned in our last session. And similarly, the diode is mentioned in the reverse bias. Diode is completely equivalent to a switch. So if we draw the electrical characteristic at this point in time, which are also known as the current voltage characteristics are the diode characteristics. I have to change the color. So at this point in time, we can show this through this blue line that 0 volts when before the 0 volts then we 0 minus. So the diode acts as an open switch, and after this 0, that 0 plus, diode will act as a switch. So the diode changes its behavior from an insulator to a conductor, which is desirable for our course in which we study this device or this semiconductor device as a switch which enable the programmable functions inside different places. So if there is any question, you can ask. Are you confused in your second groups? In some slides, going to the diode models, where the diode models are listed in table form. So this is the ideal device model. And this ideal device model, as you can see, the diode is represented with the help of a switch, and its characteristics are shown here. Similarly, in the simplified model, we have the ideal diode, which is primarily a switch, and we attach a voltage source, and that voltage source primarily make a shift in the characteristics. Primarily pick up on at 0.7 volts for the case of silicon, and 0.3 volts for the case of germanium. So शहजाद अली has joined us. शहजाद आप अपना माइक को कनेक्ट कर लीजिए. माइक आपका कनेक्टेड नहीं है, आप माइक कनेक्ट कर लीजिए. Okay, so we again, when we talk about the piecewise linear model, and in this linear model we assume there is a resistance also present in the circuit. So in the piecewise linear model, which is mostly used in practical applications, and also for simulation of different circuits, a voltage source and a resistance and a switch is used in series model in diode. So these are the primarily the diode models, the diode equivalent circuits, which are mentioned in this book. Remember, जो एक्चुअल इसका मॉडल है, जो कि शॉकली इक्वेशन की मदद से हमने थोड़ी देर पहले देखा था, उसमें जो इक्वेशन है वो इसको कुछ इस तरीके से मॉडल करती है कि इसमें हमारे पास जो है ये एक एक्सपोनेंशियली राइजिंग कर्व, इसमें एक्सपोनेंट होता है और इस एक्सपोनेंट की पावर जो है वो ग्रेटर देन 1 है, इसकी वजह से कि ये एक्सपोनेंशियली जो है ये राइज कर. So because it is rising, we in actual models we have to use the Shockley's equation, which represents a near actual model. Whereas the rest of the models which are presented in this table 1.7, they are primarily the simplified versions are the equivalent circuits. So this should be keep in mind that there are actually 4 models which are discussed in this book. So this is about diode. Now we are going towards our next section, which is related with primarily the transistor part. So we are moving towards chapter number 2. Okay, chapter number 2 deals with the diode applications. हम जो है वो किताब को ही फॉलो किए जा रहे हैं. हमारा ऑब्जेक्टिव यही है कि हम किताब को एज ए प्राइमरी रिसोर्स जो है. So in chapter number 2, we need to understand an important concept of load line, and which primarily take us what is called the operating point, which is also known as the quiescent point for any diode which is working inside a circuit. And its load line analysis and all it applies to the diode networks. Then we primarily familiar with ourselves with the series, parallel, and a combination of series and parallel diode networks, because it is important to know how those circuits actually work and what is the application of those. So also there is an important application of diode is to rectification as a use as a rectifier. Rectifier is an important process. This process converts an AC or alternating current to the a direct current. Similarly, there are also two, besides many applications, clipper application, clamper application, and also voltage multiplier application. Here, some of the important applications of a diode when it is used inside the electronic and electric circuits, and also Zener diode, which is also useful in many applications because it depicts the same characteristics but on the reverse voltage, on the application of the reverse voltage. इसको भी हम इस एप्लीकेशन के फैक्टर्स की मदद से जानेंगे. Now we move towards the load line analysis. Okay, in performing load line analysis, we consider a circuit which is shown in this figure. As you can see that a DC voltage is applied and a resistance is shown here. The voltage is measured across this diode and the characteristic curve is drawn based on the values of voltage and current which appears across this diode. As you can see, this is the same characteristic curve जो कि हमने chapter 1 में देखी थी inside the graph. As you can see, the voltage is measured in voltage units and the current is measured in milliamperes. So it is common for semiconductor devices like diode and transistors. The current is measured in milliamperes, especially for small scale circuits. So to learn the concept of load line, so load line primarily represents a line which cut this characteristic curve at a point which is called the Q or quiescent point. This quiescent point is also known as the operating point of the voltage of the diode, and at any instance of time diode Q point can be determined. It is important for the DC analysis as well as it is also important for the AC analysis. In DC analysis, there is a static Q point in which by using curve or by using the Shockley's equation, we can find the value of voltage across the diode as well as the current passing through the diode by using the characteristic curve. What are the important parameters? Consider the earlier circuit जो इससे पहले शो किया गया था. अगर आप देखें तो ये सर्किट जिसमें जो है एक voltage source mention किया गया था, and as the polarities of this voltage source are given and a diode is present in the circuit and also there is some resistance R is present. So voltage across diode and similarly the current through this diode. So because the ground side we usually mention the minus sign, not the ground side. This is how the voltage is distributed across the diode. So by these given values, because E is known value, R is a known value, we can draw a point here at voltage axis which is equivalent to E. And the ratio of E divided by R, this ratio is used to find the value of the current so that we can find another point on the y-axis. Y-axis is here is the current axis, and we know the important formula V is equal to IR. And this formula, which is Ohm's law, V is equal to E. So we can write here the current is equal to E divided by R. So because these two values are known, E and E divided by R, the ratio. So we can select these 2 points, mark these 2 points on the graph, and then join these 2 points. When we join these 2 points, and these 2 points cuts a curve at some point, and that point is called a Q point. So the Q point or the quiescent point has the characteristics primarily the voltage and current, and this voltage is mentioned as VDQ and the IDQ. Okay. So the voltage difference across the diode at Q point and the current through the diode at Q point. These are two important factors, important parameters when we analyze a circuit in which a diode is present. So I'm sure student familiar with what is a load line and how the load line is computed. Let's see if there is one example. इसमें जो है वो E और R की values given है और वो हम use करें. So I have to remove these annotations. So after removing these annotations, so this Kirchhoff voltage law application, and similarly Kirchhoff current law applications primarily lead us to determination of the load point. So the theory is given. We are not interested in the theory point. The second thing which I have told you during the load line analysis is the use of this equation. As we can see, this equation is the this equation can be used to find primarily or draw the characteristic curve, and this can also be used as a mathematical model to determine VDQ and also. But the book prefers to use a graphical representation to do that. For example, in this example, we will go through this example and then we take a short break before our next session. So in this circuit, the value of E is given, and similarly the value of R is also given. So because these values are given and also the load, the characteristic curve are given, we can easily find we can primarily easily find the Q point. So E, and similarly when we divide E by R, so E divided by R, as you can see from here, that 10 divided by 0.5, so 10 divided by 0.5, it gives us which is 20. So the next point on the line is 20. So we join these 2 points together and we get a Q point. And from this Q point, we draw a line to the horizontal axis and draw a line to the vertical axis to find the respective value of VDQ and IDQ. Similarly, we can find the voltage across R by using the formula that the voltage E is primarily divided into voltage class B and class R. So as E is known as 10 and V is from found from this part A. So by putting these values, we can find the value of VR. Now we see how this solution is primarily presented here. This example. So as you can see, it uses the equations ID is equal to E divided by R. We get 20 milliamperes, and similarly by using VD is equal to E, we get 10 volts. So we mark these points on the graph and draw a line. And after drawing that line, we then determine what is here on the x-axis and what is here on the y-axis. So we get the value of VDQ as 0.78 volts, and similarly the value of IDQ as 0.5 milliamperes by the graphical method as given in this example. Similarly, the next part is to determine the voltage. So the voltage across R can be found by using this relation that VR is equal to E minus CD. So after computation, we get the value 9.224. जी बेटा शहजाद, क्या हाल है? आप ठीक है? खैरियत से हैं?
अल्हम्दुलिल्लाह सर, बिल्कुल खैरियत। आप सुनाए खैरियत?
मैं ठीक हूँ। आप थोड़ा लेट हो गए, खैरियत?
सर वो नेट का इशू हो रहा है सर, बार बार कनेक्ट कर रहा हूँ, डिस्कनेक्ट हो रहा है सर। गाँव में हूँ सर, इसलिए।
कोई बात नहीं, हम इसकी रिकॉर्डिंग भी कर रहे हैं ताकि आप बाद में इसकी रिकॉर्डिंग जो है वो आसानी के साथ देख सकें। ठीक है
जी जी सर, थैंक यू सर।
See in example 2.2. So in example 2.2, we are to use the approximate model to find the value. And approximate model, as you can see, the approximate model from the respective table जो हमने इस क्लास के शुरू में डिस्कस किया था, उसमें 0.7 वोल्ट के अक्रॉस जो है वो हमें कर्व ड्रा करना है। जब हम इसमें क्यू पॉइंट मालूम करेंगे तो जो वीडियो क्यू है वो हमेशा सेम ही रहेगा। यहाँ इसमें ये इसलिए ये एग्जांपल जो है ये शो की है ताकि हम इस सॉल्यूशन को कंपेयर कर सकें एग्जांपल 2.1 के साथ, और क्योंकि इसकी वैल्यूज जो है वो बहुत करीब है। उसमें 18.5 मिलीएम्पेयर था आईडीक्यू, और इसी तरीके से बीडीक्यू जो था वो 0.7 से थोड़ा सा कम था। देख लेते हैं कितना कम था। It was BDQ was 0.78 volts, जबकि यहाँ पे जो BDQ अगर आप देखें तो it is primarily 0.7 volt, तो तकरीबन 0.1 volts जो है उसका डिफरेंस है इन दोनों मेथड्स में। लेकिन करंट की वैल्यूज में कुछ ज़्यादा डिफरेंस मौजूद नहीं है, which shows the potential of using the approximate diode models in different computations. इस जगह पे हम एक ब्रेक लेना चाहेंगे और तकरीबन 10-15 मिनट के बाद दोबारा जुड़ते हैं एक नए सेशन के साथ जो है हम स्टार्ट करेंगे। अस्सलाम वालेकुम व रहमतुल्लाह।